Christy, you figured it out.
I hope Alexis is starting soon, but yeah, figured it out. So we should be good. Let me make you a host, or let me make you a host.
Wonderful.
Oh,
it was the admin account. That makes sense.
Yeah. Okay, there we go. You should be a host.
Wonderful.
Wait, I think I joined from the admin when no one could enter.
Yeah, same. I did too.
Oh, okay. Are we both?
Good. Okay, let me share.
Oh, okay. It says you've been signed out because your account is signed in from another device. Cool.
Probably.
Should I let people in?
Yeah, I think we can let people in.
Okay.
Okay, cool. So I think that's the folks in the waiting room. I think we should probably go ahead and get started. As more people trickle in, we can just kind of let them in from the waiting room. I think we might as well get started. Okay, cool. Awesome. So today, I'm really excited to get to talk to you all. Oh, did I write something? Okay, it's fine. I'm really excited to get to talk to you all about building crypto protocols. So if you haven't heard of she256, welcome. She256 is a 501c3 nonprofit with the goal of increasing diversity and breaking down barriers to entry in the crypto space. And we're really excited to be partnering with Rewriting the Code for this workshop series. So Christy and Elaine did the workshop last week, and I'm excited to get to talk to y'all this week. Okay, cool. So in terms of the agenda for today, I'm going to chat a little bit about smart contracts on Ethereum. So we'll start to build a little bit of a mental model, talk a little bit about Solidity, and then the broader development stack. We'll go into building with this stack, so looking at an application overview, and then we'll actually do a deep dive into a specific protocol to understand the protocol, which will give us context to go into its smart contract architecture. And then we'll definitely chat about how you can get started and immediately kind of get running in terms of building these yourselves. So in terms of structure for each section, we're going to start with an overview, go into some specifics, and then leave you with a lot of resources to get even deeper. And I'm going to pause for questions throughout, and I'd love for anyone to jump in, ask any questions. Definitely want this to be conversational and helpful to everybody who came to hang out today. Okay, cool. So let's continue. So a little bit about me. I'm Alexis. I am one of the co-founders of Opyn, where we are building decentralized options on Ethereum, and she256, of course. And I'm really excited to get to hang out with everyone today. Okay, cool. So we can get started with talking about smart contracts on Ethereum. So the first thing I want to do is start by introducing some of these concepts so we can build a bit of a mental model about what a smart contract on Ethereum is and what that environment kind of looks like. So a smart contract is a set of code that's deployed on a blockchain. In this case, we're talking about the Ethereum blockchain. And these smart contracts contain both logic and the ability for us to make transactions. So what do each of those things mean? Logic you can think about as very similar to any other computer program. It's your if-else statements, it's your loops, you're trying to tell a program exactly what it's supposed to do. So a pretty common piece of logic that we'll see in a lot of smart contracts is, hey, has this user said that I can spend their funds? So in the Ethereum environment, a user actually has to give permission to a smart contract for that smart contract to spend that user's funds. And so pretty commonly, if you're reading smart contracts, you'll see something like, if user has approved X coin, then take some action. So that's kind of what we mean by logic. And then when we look at transactions, that is actually what's changing the state of this kind of distributed computer. So if you think of Ethereum like a giant distributed computer, kind of like you learned about last workshop, you can think of any of these transactions as something that is changing the state. And so these can be things that are really simple, like one user sending funds to another user, or a user actually giving permission to another contract to spend its funds. Or they can be really, really complicated, where you're taking lots of different financial actions in one transaction. You might go put down collateral, take out a loan, make a trade, and then input the new output of your trade into another platform as collateral, all in one transaction, changing the state of this entire blockchain. And we'll dive a little bit more into those more complex transactions later on. But there's a lot of power and a lot that you can do with this kind of model with your logic and transactions. So some other really cool things about Ethereum being this global distributed computer is that all code is public. This isn't like the traditional world where we have things closed source that people can't see. Everything is verified on chain. And most of this code is immutable, meaning that once it's there, you can never take it down and it can never change. Now, I caveat that saying most because there are ways to upgrade smart contracts, and we won't get into that today, but that's something that's really interesting and something that some protocols do approach, and it's something that as a user, it's important to be aware of. Okay, so that's a little bit about smart contracts. Now we can chat about some of the types of actors that you can interact with on-chain. There are two key actors that we'll talk about. So the first is something called an externally owned account. So this just means a human with a private key. So you can think about this as a wallet, like your MetaMask wallet or your mobile wallet. And this just means that there's an actual person taking an action, like a person sending a token to another person, or a person approving a smart contract to spend their funds. So that's all we mean when we say externally owned account. Now, the other kind of actor is actually other smart contracts. So something really cool is that smart contracts can talk to each other and they can send each other funds. And this is how you get those more complex transactions like we were talking about before, where you're taking out a loan and making a trade all in one transaction. That's two different smart contracts talking to each other to make that kind of thing happen. So that's kind of the different kinds of actors that you'll see on chain and the people in this environment. Something also that I think you all probably talked a little bit about last week was miners and how transactions get submitted to the blockchain. But something that's important to think about when you're developing smart contracts is, how do miners decide what transactions to include? Well, that's where we learn about the concept of gas. So for every single transaction, whoever's sending that transaction, whether it's a user or smart contract, has to pay gas. And this is basically like a fee that goes to miners that incentivizes them to include that transaction in their block. And so the gas fee, which is what you ultimately pay, is a combination of two things: the gas price and the gas limit. The gas price is set by supply and demand, and you can think about that as the price of sending a transaction. So if there's a ton of people that want to make a transaction right now, then the gas price is going to be pretty high because there's a lot of demand. The gas limit is how much gas your specific function call is going to take. So if I'm trying to do something pretty simple, like give permission to a contract to spend my funds, I'm going to have a pretty low gas limit because that's not going to take that much gas. But for these more complex transactions that are combining different smart contracts, that's going to have a much higher gas limit and cost me a lot more gas. And so recently in the Ethereum environment, we've been seeing really high gas fees, and that's a big thing that users have been thinking about as they decide what contracts to use. So as a developer, it's an important thing to take into account because it's a fee that the end user ends up having to pay. And something really interesting, because we have this concept of gas in the smart contract environment, is that developing smart contracts actually monetarily punishes complexity and rewards simplicity. The more simple your transaction is, the less gas it's going to cost. And then I also wanted to mention security. So Ethereum and a lot of these smart contract platforms are very new and experimental technology, and it's been crazy to see billions of dollars in these different kinds of smart contracts. And so as a developer, especially developing smart contracts, security has to be a really big consideration because these are so new and we've seen so many different incidents happen. So some ways to go about developing in a secure way are test-driven development. So figuring out what you want to build, writing tests first, and then building your smart contracts out. And you can kind of think about smart contract development as almost even a little more similar to hardware development than software development, especially if your contract is going to be immutable, sitting on chain, and you have no way to change it. And it's going to be holding all of this money. So it's definitely interesting to see teams in the space take different approaches, taking into account these security considerations. Okay, cool. So I'm going to stop for questions there because that was kind of a lot of information. So I'll take like one or two and then we can move on to the next slide. And I can just check the chat, I guess. Okay. All right. Well, looks pretty good right now. Okay.
Earlier up in the chat asked, is there a ceiling to how much the gas surge or gas can surge up to?
That's a good question. There isn't really a ceiling on gas price, but there is on gas limit because every block has like a certain limit of transactions that it can contain. So you can't have like a transaction that goes beyond the block, otherwise it will revert. But that gas price can get pretty crazy.
To elaborate on that, what is the model behind that? Like, how is the model built in? And then I guess it knows how to search up and down.
So it's pretty much based on supply and demand. So basically, like if the miners are basically going to take the what's going to give them the most money. And so if there's a lot of people trying to get in a transaction at a specific time, then if you want your transaction to get in ASAP, say you're trying to like make a specific like arbitrage trade or something, and you set your gas price a little higher, that miner's going to take it first. And then everyone else who wants to make that trade is going to be like, oh, okay, now I want to set my gas price higher to get my transaction in first. So you can think about it pretty similarly to supply and demand in any other market.
Got it. It sounds like more like auctioning too.
A little bit, yeah. There's a lot of really interesting like mechanisms behind the gas stuff. So I would definitely recommend looking into that if that's something that's interesting.
Okay, thank you.
For sure. Okay, cool. So I'm going to move on to the next slide. So the next thing I want to talk about is how do you actually write a smart contract? So the way to write a smart contract in Ethereum is to use a language called Solidity. And so this is like Ethereum scripting language. It's kind of like JavaScript in its resemblance. It was also written very quickly, like JavaScript. So it has a lot of those quirks of a language that was spun up in a short amount of time. And then there's also a language called Viper, which is more similar to Python, but you'll see that Solidity is pretty much the de facto language that the space has adopted, where you can find the most tools and resources. And this is kind of the standard. And all of the Solidity code gets compiled on something called the Ethereum virtual machine. So this Ethereum virtual machine, the EVM, is compiling this Solidity into bytecode, so it can then get executed. So all of these different Ethereum nodes are running the EVM. And technically, you can write any program in Solidity just like you would in real life. Like if I wanted to write like tic-tac-toe in Java, I could also write tic-tac-toe in Solidity. But there are certain things that make sense to write in this kind of environment and certain things that might not. So things that might make sense are things that really take advantage of the properties of building on chain. So some of the stuff y'all touched on last week, like censorship resistance, transparency, composability, being able to put different transactions together. And when we're talking about DeFi or decentralized finance, being able to have quicker settlement, availability to anyone, anywhere, and full permissionlessness. So I do think that's something important to think about when you're building smart contracts, what actually makes sense to build out as a smart contract. So I'll pause there to check the chat. How would I explain gas to be, okay. Gas in Bitcoin. Yeah, it's a good question. So in terms of developing on ETH versus Bitcoin, so with Bitcoin, you have like, I've never developed on Bitcoin, so I'm not the expert here, but I know there's like a scripting language and there isn't something like Solidity where it's very familiar to different developers and you're a lot more constrained with what you can actually do on Bitcoin in terms of actually building programs. Whereas with Ethereum, you have an almost Turing complete language constrained only by gas. So there's a lot broader of a scope of what you can do. Okay, cool. So in terms of getting started with writing smart contracts, this is a set of tools that can help you get started. MetaMask is an in-browser wallet. Remix is an in-browser development environment. Scaffold ETH is great. It's basically like this GitHub repo that has a lot of Solidity templates using some of the really popular protocols on chain. Crypto Zombies is a wonderful set of tutorials for learning Solidity. And once you really get into development, Hard Hat is an amazing kind of set of tools that help you develop more efficiently. These are all linked here, and so you can check them out once we share the slides later. So the next thing is once you've written your smart contracts, how do people actually use them? Well, like we talked about before, these smart contracts, once they're on chain, are immutable and anyone can access them and anyone can see them. So there's a lot of different ways that people can actually start using them. They can literally call your contracts directly. So they can just call your functions in code and that's that. You know, you don't have to provide any kind of other infrastructure. They can use interfaces like Etherscan. So Etherscan is a block explorer, which provides an interface that just shows you the method of every single smart contract. So you can just call different methods and put things together. Definitely not the most user-friendly way to do things, but a reliable resource if you can't access a project's front-end interface for some reason. And then of course, the most popular way is accessing smart contracts through traditional front-end interfaces. And the cool thing here is that there's we've started to build out a whole stack on how you can build on top of smart contracts. So there are platforms like the Graph, which kind of index all your data from smart contracts that's on the blockchain and let you access it with GraphQL queries. So it feels very similar to accessing a traditional database, like from a front-end development point of view. And there are APIs like ethers.js and web3.js that also help you make and send transactions and gather data on chain. And you'll see a lot of front-end interfaces in the space built with a very similar stack to what you're used to, whether that's React or Vue, TypeScript, JavaScript. And so that's typically how folks are able to access these different smart contracts. And the really cool thing is because these smart contracts are all public, anyone can build an interface on top of them. There's no such thing as like a closed or permissioned API that you see in traditional computing or traditional tech. These smart contracts are open. And I think a really fun example of this is there's this protocol called Zora. They're an NFT protocol, and they are a set of smart contracts. They released a front-end interface, but they blocked it off. So you could only access the front end if you had an invite. And so this developer, even before Zora opened up their front-end interface, literally built an alternative interface using the smart contracts, front-run the actual company, and gave anyone access to be able to see what was going on chain. And this is the kind of thing that can only happen in crypto. And it's kind of crazy. And even today, you can technically only create on the Zora front end if you have a creator invite, but using Zora.gallery, this open source interface, anyone can create anything. And so I think this is like just such a clear example of how cool things can get when you have actually open, permissionless, and composable technology. So in terms of getting started building on top of smart contracts, these are a couple of resources. So I mentioned the Graph, Ethers, and Web3. If anyone's heard about Create React app, we have Create ETH app, which makes it really easy to get started with building a front-end interface. And there are also tools like onboard.js, which is a really easy way to connect a ton of different wallets to your app. So it lets you easily connect MetaMask, hardware wallets, mobile wallets, makes that process really seamless. And building on top of smart contracts, I think, is a really good way to get started. It helps you understand the best practices and smart contracts that others have built. And it lets you be really creative and do really fun things like build alternative interfaces into your favorite protocols, or look at a user group that maybe isn't being served by an existing protocol and take advantage of that opportunity. Okay, I will pause for questions before I jump into kind of the next set of topics. So let me jump on the chat.
Yeah,
okay.
me and Meta have been kind of answering questions.
Oh, perfect. Wait, okay, that's great. Then I'll just keep going. Thanks,
Yeah,
Christina.
actually, there was one question earlier in the chat where someone asked, why can't like the kind of code functionality, smart contract functionality be added to Bitcoin over time?
A good question, and it totally could be. But what's really interesting is that the reason that Ethereum was created in the first place is because there was a lot of resistance in the Bitcoin community to creating this functionality within Bitcoin. And so it's still totally possible. It would just require convincing a lot of Bitcoiners to implement something like that. And I don't think they're very excited about implementing something like that from a community standpoint, but definitely worth a shot, maybe. And that's another interesting thing about these protocols, is that a lot of these kind of consensus elements happen kind of off chain and based on like the preferences and the values and ethos of these different communities. Okay, cool. So yeah, what can we build with this stack? Well, a lot of the stuff, pretty much everything you talked about last week, you can build with this stack, whether we're talking about decentralized finance or NFTs or things that no one's even thought about yet. So really exciting space, lots of cool things to build. And today I'm going to focus on DeFi, or decentralized finance, just because that's what I'm most familiar with. So we'll be focusing mostly on that today. And so I wanted to talk a little bit about why it matters. Like, why is building with smart contracts for decentralized finance different than building with, the APIs and the tools that we already have in the centralized finance or centralized tech world? So we've talked a little bit about these properties of openness, permissionlessness, and composability. But the crazy thing is, like, these things are legitimately accessible to anyone, anywhere to build or use. I'm not, it's a Sunday or Sunday or Saturday, and I can send a transaction. I don't have this bank being closed situation. It's like 5 p.m. Pacific and the bank is open because the normal bank closes at 2 p.m. Pacific. And I'm always like, oh man. So that just doesn't exist in crypto. And those are things that most people are aware of and most people are excited about, but they still feel so magic. And so when we're thinking about the traditional finance system or even fintech companies that are kind of newer finance, they're all building on the same old plumbing. And I think we've seen this with Robinhood. Like, Robinhood is this new, beautiful interface that feels very, very different, but it's built on the same old plumbing. So as we saw with the whole GME situation, they still have these T+2 requirements, and they're still built on the same old financial plumbing that's existed for hundreds and hundreds of years, or maybe not hundreds and hundreds, but maybe about 100. And the reason that hasn't really changed is because at the end of the day, to build a fintech company or something like that, you have to get permission from these banks. And they don't really want to give permission to the people that are going to disrupt them. And so the cool thing with DeFi is that we don't have to get permission from banks. And we aren't just putting beautiful interfaces on top of old plumbing. We're actually building new plumbing from the inside out in what seems to be a much more scalable, inclusive, and transparent way. And so that's really exciting. And we'll talk about this a little more later, but it's insane the amount of leverage that you can have by building with smart contracts. Like, literally one person can build a decentralized exchange, or a group of a couple people can build a margin trading platform. And that's just unthinkable in decentralized finance. And we're still in the extremely early days. There's still a lot that we can build. And so it's pretty exciting. And so definitely very, very hyped about the possibilities here. So in terms of getting started with learning about DeFi applications, I listed out a couple here that you can check out later. I'll talk about them briefly right now. This is just a very small subset of a ton more. We've seen incredible innovation in the DeFi space, but these are a couple. So we've got Maker, which is building a stablecoin. So a stablecoin is a currency that is one-to-one with the US dollar. Compound, which is building a lending platform, Uniswap, which is a decentralized exchange, DYDX on margin trading and perpetuals, and then Opyn, which is building options. Okay, so now we're going to kind of do the second part of the workshop, which is a deep dive into a protocol and then talking about the smart contract architecture. I'm going to focus on Opyn because that's what I know best and what I can speak to the most. And so the way we'll structure this is we'll talk a little bit about options to build the understanding we need to go into the protocol. Then we'll talk a little bit about the protocol works, and we'll end with the smart contract architecture itself. Okay, cool. I'm going to check the chat really quick. How are we doing over there? Good? Okay, amazing. Cool. So then we can dive into Opyn. Okay, cool. So the first thing that we can talk about is what is an option? So the definition of an option is something that gives you the right, but not the obligation to sell an asset, which we call the underlying, at a given price, which we call the strike price, by a certain date, which is our expiry date. And this is kind of a mouthful and a lot of words. So let's go through an example and then come back to the definition. So let's say that ETH is at 2K. Very exciting. We're all excited. But we're also a little bit worried about ETH downside, volatility, and flash crashes. Then what we can do is buy something called a put option, which little typo here, but a put option basically says, hey, if ETH price falls below 1800 before a specific date, let's say June 7th, I can still sell my ETH for 1800. So say like I wake up and it's like June 7th and ETH has like tanked to 1K from 2K. Even though ETH is trading at 1K in the market, I can actually use my put option and still get 1800 for my 1 ETH. And so that's kind of the power of this put option, where it's giving me the ability to hedge my downside. So let me know if that makes sense. Okay, feel free to drop in any questions. Okay, cool. So yeah, going back to that definition, just to talk about some of those terms I'd mentioned before. In this case, ETH is our underlying asset. 1800 is our strike price. So this is the price where if ETH hits 1800 or falls below 1800, I can exercise my option and actually get that 1800 for my 1 ETH. March 7th, okay, June 7th, so clearly some typos, is my expiry date. So basically the date up until which my option is valid. And then a really key part here is that I have the choice to sell my ETH for $1,800. So this means, this is what we mean by right, but not obligation. So if I woke up on June 7th and ETH was actually $3,000, I am not obligated to use my option to sell 1 ETH for $1,800. I can go out into the market and sell my ETH for that market price of $3,000. So the only time I would actually want to use this option is if ETH actually did fall in price to below 1800. Okay, cool. So there are 2 types of options. So we talked about the put option. The other type of option is a call option. And so a call option gives me the right to buy ETH. So the put option was giving me the right to sell ETH. The call option would give me the right to buy ETH. So for a quick example, say that I'm super bullish on ETH. I'm pretty sure it's going to 5K. Then what I can do is buy a call option with a strike price of $3,000. And then say I come around to my expiry date, ETH is at $5,000. I'm super excited. Instead of having to buy ETH for $5,000 at the market price, I can exercise my call option and buy ETH cheaper at $3,000. But if ETH went down to $1,000, I wouldn't have to use my option and buy ETH at 3,000. I could still go into the market and buy ETH for $1,000. So that's what a call option is. And so a common confusion is that, hey, is the opposite of buying a put, buying a call? And no, there are actually 4 kinds of actions we can take with options. We can buy a put, we can sell a put, or we can buy a call, or we can sell a call. And these are 4 distinct financial transactions with 4 distinct financial payoffs. And so when you're buying an option, you're actually paying a premium to get this optionality. You're like, hey, this sounds like a pretty good deal. If I'm buying this put option and ETH goes down, I still get my 1800, but if ETH goes up, I don't have to use it at all. Like basically what you're getting is optionality. And because that's a pretty good deal, you have to pay for that. And we call that a premium. Now, when you're selling an option, you're the person that's getting paid that premium. When you're selling the option, you're taking on an obligation. You don't have a choice. If the user wants to exercise their option, you're obligated to take the other side. So why would you take on this obligation? Well, you do get paid for that, which is getting paid that premium. All right, I'm going to pause and see if anyone has any questions here. Okay, cool. So you can buy an option at any time up until the expiry date. How much does it cost? How is the cost for an option calculated? Oh my gosh, that's a really good question. I'm not going to dive fully into it now because it's actually pretty complicated, but there's some different factors. So there's supply and demand, just like with any other asset, but there are also factors like time decay. So for example, if an option is going to expire in 1 month, then it has 1 month to hit the strike price, versus if it's going to expire in 1 week, it only has 1 week to hit the strike price. So that option that's going to expire in 1 month might actually be more valuable because we have more time for it to hit the strike price. Another thing that we take into consideration is the volatility of the underlying asset. So if the asset is really volatile, that would be, taken into account the pricing compared to an asset that isn't very volatile. Option pricing is super interesting, and I'm more than happy to share resources to dive more into that as well. Okay, cool. Okay, so that was kind of our option overview. Now I'm going to go into the Opyn protocol, and I'm going to start by talking about Opyn v1, since that's a bit simpler. And then at the very end, I'll talk about how Opyn v2 builds on top of Opyn v1. We'll start with the protocol, and then we'll use that understanding to dive into the smart contract architecture. Okay, so in terms of Opyn v1, if I was a user and I wanted to go out and buy an option, I would go to an exchange. In Opyn v1, we used Uniswap, and I would pay the premium like we talked about before, and then I'd get back from the exchange an O token. So basically our options are called O tokens, and an O token is an ERC20 asset. So ERC20s are basically like a token standard on Ethereum. And that means that any of these option tokens can pretty much trade on any decentralized exchange. So with V2, they're trading on Uniswap. Different developers building on top of Opyn have had O tokens trading on different places like Balancer. And so that's the amazing thing about the ERC20 standard in Ethereum, is that it makes all of these different protocols able to talk to each other. So that's kind of how you buy an option. It's pretty simple. I just go to Uniswap, pay a premium, get my option. Okay, now what can I do with my option? Well, there are 2 things. What we talked about before was exercising the option. And so this is like what we talked about where, hey, it's June 7th, ETH fell to $1,000, and I want to basically use my put option to sell my ETH for $1,800. So then as the option buyer, I would send my ETH, and I'd also have to send my options, my O tokens, to the option sellers. And then the option sellers would send me that strike price amount in USDC. So in this case, $1,800. Now, the other thing that I could do with my option is I could actually sell it. Because it's this ERC20 token, because the option itself has value like we talked about, I can go back to that exchange and sell my O token and receive some premium for selling it. So those are the 2 things that you can do with your option once you've purchased it. Now, what about taking the other side to sell options as an option seller? So as an option seller, what I do is, let's say I'm selling a put option. I put down some USDC into what we call a vault, and I'm going to be using this USDC as collateral to mint my options. So these US dollars are going to be what's backing the options that I'm minting. So then I mint some options. So for the example we were talking about before, I would put down 1,800 USDC in order to mint one O token with a strike price of $1,800. And that would basically be the backing. So if a user wanted to come exercise, they'd be able to send me their one O token and their one ETH, and then they'd get my 1,800 USDC. So that's how I put down my collateral into a vault and mint my O tokens. And then I take those O tokens, which I've minted, and I sell them to I sell them to buyers on the exchange, and I get my premium immediately in return. And the cool thing is, using smart contracts, like we talked about before, we can take this multi-step process and have it done in one transaction to make it really easy from a user standpoint. But this is kind of what's happening with the protocol in the background. Okay, I'm gonna stop for questions here before we get into the architecture. Okay, cool. Question from Christy. How do ERC20 tokens work? Is ETH and ERC20? Good question. So that's a really good point. ETH actually is not an ERC20 token. And that makes things pretty tricky for development. And okay, yeah, Sarah mentions in the chat talking about WETH. Exactly. Makes sense. Yeah, yes, trading for the O tokens does cost gas. Correct. And so right now gas fees are pretty high. And so a lot of different projects are looking at layer 2 solutions to mitigate that, but definitely something that's taken into account. Okay, cool. So now let's talk about the smart contract architecture for V1. So the V1 smart contract architecture followed something called like the factory pattern, which is something that Uniswap kind of came up with that we adopted for V1. So I'll explain how we're doing it with Opyn V1, and then I'll talk a little bit about how Uniswap did this in the first place. So we have a main contract called the factory contract, and this factory contract can create different option series. So for example, I could create that 1,800 ETH put option, and I could create that 3,000 ETH call option, and then I could create a Bitcoin option. So this factory can spawn multiple series by calling a create options contract function. And anyone can go to this factory and anyone can create a new option series, which is pretty cool. For the first time ever, anyone can create an option on anything. And then from these different series contracts, people can come in, put down collateral, and mint these different O tokens. And so the way that Uniswap kind of came up with this initial factory architecture was Uniswap is a decentralized exchange. So different pairs can trade against each other, whether that's ETH trading against DAI or USDC trading against Uni. And so anyone can come into Uniswap's factory contract and create one of these exchange pairs, whether that's like ETH Uni or USDC DAI or whichever pair they want, and they can provide liquidity for it. And so it's very similar to this kind of factory architecture. So you'll see that in different smart contracts that are on chain. Okay, so the next thing I'm going to talk about is basically from the sell side, actually opening up a vault, putting down collateral. So it says repo here, but now it's called a vault. And so this is very similar to MakerDAO. So MakerDAO, which is the stablecoin we talked about earlier, you put down collateral into a vault and you mint the stablecoin DAI. Similarly here, I'm putting down collateral into a vault and I'm using that to mint options. And so once I've added my collateral to the vault, that is going to enable me to actually issue the options. And so I can also add additional collateral after I've added my first set of collateral, and then I can issue my options if it's before expiry. So for example, if I put down $1,800 of collateral, 1,800 USDC of collateral, and I minted one option, and then I decided, hey, I actually want to mint another one, I could put in another 1,800 and mint another option. Okay, and then say that I'm a seller and I want to close out my position early. What I can actually do is I can go to the exchange, I can buy back some of those O tokens I sold, and then I can burn them. And burning them allows me to redeem my collateral. And so this is very similar to the architecture that MakerDAO uses in DAI, where if I've minted some DAI and I want to close out my vault, I go to an exchange, I buy DAI, I burn it, and then I can redeem my collateral. So very similar structure. I mean, this is another kind of common pattern that you see in different smart contracts where if you've issued a token, you can go back, buy it, and burn it to redeem the initial collateral that you put up. And then, of course, you can exercise and redeem your underlying if you hold the option. And so if I'm exercising, what I'm doing is, like we talked about earlier, sending my underlying asset, which in our examples has been ETH, and my O tokens and receiving the USDC in return. And so what's happening in the background is we're looking at these different vaults that these sellers have, and we're choosing a vault on which to exercise upon. And then on the other side, after expiry, if I'm a seller, I can come back to my vault and I can redeem the collateral that's left. Okay, so that's a bit of the V1 contract architecture. I'm going to pause for questions if anyone has any, and then I'll talk a little bit about how V2 kind of expanded on V1. Okay, any questions there either on the V1 architecture or some of those kind of common smart contract patterns that you might see? Okay, cool. So in that case, I will continue. So some of the big considerations with V1 were the simplicity. At the end of the day, it was a factory that produced O tokens and then had this kind of vault architecture pretty similar to MakerDAO. With V2, we were able to expand upon this. So you still have this very core idea of like a factory that spawns O tokens, but we were able to really take into account a lot of the user feedback and introduce a little bit more complexity to add some of these things that users were asking about. So here's the basic kind of infrastructure, and then this is kind of how it expanded. And I can talk about this a little bit more. And I'll talk about kind of first at a high level, some of the features that this enabled, and then I'll dive into what some of these things actually do. So some of the cool features that this enabled are something called spreads. And spreads mean that I can collateralize one option with another option. So what does that actually mean? So say I wanted to sell that $1,800 put. What I could do is I could go out into the market, I could buy a $1,700 put, and I could use that $1,700 put plus an additional $100 to collateralize my $1,800 put option. Because then in the case that ETH falls in value, what I can do is I can actually exercise my $1,700 put to get that $1,700 and then use that additional $100. And so this is something that we call a spread, where we're using one option to collateralize another option. And so this improves capital efficiency because instead of having to put down $1,800, I'm putting down $100 plus the cost of buying that other put option. So that's something that this new kind of architecture has allowed us to enable. Another thing that we've been able to add is something called an operator. So an operator is an external smart contract that you can give permissions to, and that operator can do things for you. Like say your option is expiring and you want to roll over to the next expiry. So my option expires on June 7th. I still want an option. I still want to keep having my ETH put option. I want to kind of expand this to November 7th. This operator can roll your option for you, buying the November 7th option. So you don't have to think about it. You've just set it and forget it. The operator can also act kind of like a portfolio manager, buying and selling different options for you at different times. So it gives developers a lot of flexibility and a lot of power to create some really cool applications that can help users, with their options kind of journey. So those are some of the interesting features. There are also things like we see here where we can use assets like C tokens, which are basically interest-bearing collateral. So collateral that's in that compound money market, and we can use it as collateral for options. So my collateral is actually earning interest. So this is something that the contracts enable that the front end, we haven't even enabled on the front end yet, but it's a cool thing that's available at the contract level. and a bunch of other really interesting stuff that I can get into if there's interest later on. But there's a huge, huge design space in terms of what you can do with contracts. And kind of the way we approached it was starting with really simple first, validating the idea, getting a lot of user feedback, and then trying to design a platform that kept things as simple as possible, but also enabled users to access those more advanced features that they were looking for. Okay, so the next section, we'll talk a little bit about how to get started, but we'll pause for questions. So question from Meta, without using a front end, how do you run a smart contract? That's a really good question. So there are a couple ways to do this. So one thing you could do is use something like Etherscan, which we can talk about, which is technically a front end, but it's a like Block Explorer kind of front end. And I'd say this is like well, we can just see if people have been doing interesting things and see if any of these are a contract. This is just a transfer. I probably have some. Okay, I'm not gonna dox myself actually. So we'll find some later. But basically Etherscan, if you wanna go to the website, you can find a smart contract and you can actually call contract functions from there. But if you want to do it completely without using something like Etherscan, you can actually just like use something like ethers.js or web3.js, those APIs we talked about earlier, and directly write code, either whether it's smart contract code or like JavaScript code, to be able to create transactions and send them to contracts. So that would be the best way to go about doing that. Okay, cool. So in terms of how to get started, in terms of learning to build applications, in addition to everything we talked about in the first section, I would highly recommend Blockchain at Berkeley's developer course. Open Zeppelin has some really awesome resources like Ethernaut and Damn Vulnerable DeFi for understanding smart contract security. And then ETH Global runs really, really great hackathons where you can meet other people who are working on this kind of stuff and give yourself a forcing function to ship something really cool. In terms of learning about DeFi, the Defiant is a wonderful newsletter that pretty much covers everything happening in the space. And what I've linked here is actually their guide, their DeFi guide, so it's pretty comprehensive. Linda Shi has a really great blog post, Beginner's Guide to DeFi. Bankless is another good newsletter, Crypto Twitter, and I have Discord in all caps here because legitimately, like, every DeFi project has a pretty thriving Discord. Lots of people are hanging out there, just chatting about these protocols, asking each other questions, thinking about a lot of the open problems that exist for these protocols. And so it's a really, really great way to get involved and ask a lot of questions. In terms of using applications, MetaMask for web, Rainbow and Argent are some great mobile wallets. Instadapp just released something, which is like a test environment. So because there's like a lot of high gas right now, this is a fun way to try things out in a kind of more simulated environment. And then of course there's testnets, which is really, really necessary for development, especially right now with gas costs so high. So these testnets are basically using like fake ETH, but simulating, you know, your normal mainnet environment. So you can actually test out your smart contracts without having to pay real money. And then in terms of contributing to the space, there are so many ways to get started. Like I said before, everything is, you know, on chain, every smart contract is available, even if their repo isn't open source. But most of the projects in the space do abide by this open source ethos and really, really do welcome contributions. So jumping onto these projects' GitHubs, looking at issues that say good first issue, asking the folks in Discord how you can get started is a really good way to start contributing. Another big thing is governance. A lot of these protocols are decentralized and are looking for people who really understand their protocols to help make decisions. And so this is an incredible, incredible way to get involved. You literally get to think about the protocol architecture. You get to think about, you know, what should the next smart contract upgrades be? What do users of this protocol want? And really, really provide input. So governance is something that's really sparking up now and a great way to get started. Gitcoin is an awesome platform where different projects will put up bounties for developers. And so you can come and basically do any of these kind of tasks that projects are talking about, and then ask lots of questions. This community is honestly really, really friendly and really welcoming to people who want to get started. And so definitely ask lots of questions. And then she256 has some resources as well that I definitely have to mention. So there's our new Discord at tiny.cc/she256 Discord. Highly recommend joining. Great place to have conversations. We try to tweet things that are useful and interesting. We have our third iteration of our mentorship program coming out later this year. So that's going to be exciting. That's an opportunity to connect directly with a professional in the space, or to give back and mentor someone in the space, someone who wants to get into the space. And then we have our job board, which is going to be coming soon as well. And so Christy actually ran a pilot of that last year, and the full iteration is going to be coming out as well. So that'll be a great way to actually get jobs in the space. And then with kind of those resources out of the way, I want to talk a little bit about some of the open problems in this space. Like we've talked about earlier today, gas is a big problem. So scaling is something people are thinking a lot about. And then also composable scaling. If different projects are moving onto layer 2, how are they going to be able to talk to each other? How do we make that simple and easy? One of the biggest benefits we have right now of being on Ethereum is this composability. Is that I can, call a function from a lending platform and then call a function from a decentralized exchange, and, so on and so forth. So how do we maintain that? Another thing is identity. So this is something that's been interesting, especially with NFTs. How do I prove that the person who minted the NFT is the person who actually made it? And how does that, fit into how we value those NFTs? Capital efficiency. So I was talking about spreads earlier, but at the end of the day, one thing that traditional finance has going for it that DeFi doesn't as much yet is that it's a lot more capital efficient. I can put down a lot less funds to create the same positions that in traditional finance than in DeFi. And so that's a big focus area. Another thing is UI UX, with having users having to understand things like gas and use stuff like MetaMask. Sometimes it can be a little bit tricky or intimidating for folks. And so improving the UI UX, making sure folks understand the risks, both the financial risks and the security risks of what they're getting into, is really important. And literally every protocol has their own open problems. So if you hop into their Discord, they'll be more than happy to share and more than happy to bounce off ideas together. And then lots of stuff that nobody's even thought about yet. And the cool thing about this space is the insane impact you can have, because we're so early. And this is one of my favorite examples. So this is a blog post from Hayden at Uniswap, which is a huge decentralized exchange. He was literally a mechanical engineer. He had just, done his first job in college, and he got laid off from his job. And then his friend Carl was like, okay, that's awesome. Now you can focus on Ethereum. Hayden had literally never coded before, and just started to build Uniswap to learn. And today, Uniswap, which was 500 lines of code from one developer, reached over 100 billion cumulative trading volume, which is insane. And like we talked about earlier, because we're not interacting with these old banks and these old APIs, and we're building with smart contracts, the leverage that a single builder can have is insane. We're looking at an environment where 3 people can build an options platform and 1 person can build a decentralized exchange, which is literally unheard of. And so the leverage that each and every one of you can have developing on Ethereum is crazy and incredibly, incredibly exciting. So very excited about the impact that folks can make. And then another thing I really want to emphasize is that we all believe in crypto. We know crypto is going to shape our future financial and governance futures. And it's really, really important that those of us building these systems are representative of the global diverse population, which we want these platforms to serve. We need more people in crypto building applications who look like our global diverse population, who look like the people we want to serve. And so it's really important and really exciting, and a huge opportunity for those of you who are interested to start working on this stuff. Okay, cool. So thanks for hanging out with me for like an hour and talking about all this stuff. Definitely would love to take some questions in the time that we have left. And then our Discord community, I'm going to plug again, because it's a great place to continue talking about this stuff and asking questions and stuff like that. Okay, cool. So I can jump in the chat, and also if I don't, Christy, I'd be curious how you guys did this last time, but if people want to just shout out questions or chat, or what worked best.
We had a combination of both last time.
Okay, awesome. So yeah, feel free to toss questions in the Slack. Feel free to just shout them out and we can chat.
I actually had a question from earlier that I don't think we got to.
Awesome.
But So to my understanding, O tokens each have a different strike price and expiry because they represent a different option. So wouldn't that require like for them to be non-fungible?
So yeah, that's a good question. So each O token is non-fungible with each other, but fungible within a series.
Okay.
So let's take our put option example. So all of the $1,800 put options expiring on June 7th, those would all be fungible with each other, but they would not be fungible with the 1,800 put options expiring on November 7th. And so definitely, like, just like in traditional finance, it's important to have like kind of a select few different options that you're building a lot of liquidity around. Otherwise, you do have this like liquidity fragmentation if you have too many trading at too many different strikes.
Okay, sounds good. So for my own understanding, what's the technical standard that those O tokens are built on top of?
ERC20.
Okay. Interesting. Okay.
So it's the same way that like DAI isn't fungible with USDC, but all DAIs are fungible with each other. That a 1,800 June 7th put would be fungible with all other 1,800 June 7th puts, but not with the November 1,800 puts.
Okay.
Does that make sense?
They're not like ERC, like 1155s.
No.
Okay. Got it.
I could technically create like a Uniswap pool for like the November ones and the like June ones and trade them with each other, which would be interesting. I don't know why people would want to do that financially, but technically it's possible.
I had a question from like a developer's point of view. What do you think are some of the main reasons why there are so many smart contract exploits and hacks?
It's a really good question. Developing on Ethereum like securely is incredibly difficult. The platform itself is still very young and experimental, and there are so many small things that can go wrong. And because these exploits can be so profitable, there's a lot of people who are incentivized to comb these contracts and find any opportunity to exploit. It's a pretty adversarial environment. If you can be exploited, you will. And so it's really, really important to like think about security as a first principle when you're developing contracts, all the way from tests to pull request review to peer review to smart contract audits. And we've seen this kind of huge business spin up around smart contract audits, and the costs skyrocket and demand be crazy. Like if you want to get an audit from a top firm right now, it takes like months to book them. So it's definitely like a clear kind of problem where it's like building this stuff is like not building this stuff securely is still incredibly difficult. And if there are ways that, and there are things that help. So for example, like the ERC20 standard is something that's been audited and used so many times that we're all like pretty confident that that's safe. So the test of time is like a big thing, and also smart contract standards that are reusable. Let me know if that answers the question. Okay, cool. Other ways to get involved. Yeah, there are so many ways to get involved. And I think a big one is governance. You don't necessarily you don't actually need to have any coding experience at all for thinking about governing a protocol. You can just come in as a user and give your feedback and your thoughts, or from a protocol perspective, give feedback and thoughts, understand the other people in the community. And because these protocols are decentralized and they're governed by communities, building those communities is actually incredibly important. So folks that can do that are honestly in really high demand right now. Like I think the top like positions I've seen people hiring for are like Solidity engineers, community managers, and front-end engineers / designers. Okay, cool. Does anybody have any other questions? We are at time, but I'm down to hang out for a couple more minutes if anyone has any questions. Otherwise, would love to see everybody on the Discord, and we can continue lots of discussions there.
I have one question. So earlier you had said like the ERC token is like the standard, so people trust it. How long ago was that established, and had it have, I don't know, it's like the proper term, upgrades or something like that since?
Absolutely, it's a good question. The ERC20 standard, oh my God, it's been like a long time, like pre-2017. I know it existed when I got into this space already. So it's been around for a long time. I don't know that there have been any big considerable updates to it since. So it's kind of just hung around and really stood the test of time. All right, Sarah's saying it was 2015. Yeah, so it's been around for a while. One interesting thing is Sarah was talking about WETH earlier, and WETH actually, like, people just proposed an upgrade from WETH 9 to WETH 10. And so it'll be interesting to see if people adopt that. WETH, again, is wrapped ETH. So it's ETH in the form of an ERC20 token. And WETH 9 has been the standard for a while. And so I'm curious personally to look into WETH 10 and see how people adopt it. Is it WETH or WETH? I don't know. I say WETH.
I have a kind of random question.
Yeah, for sure.
With Ethereum versus like Polkadot versus Cardano, why do you think Ethereum is more superior? Obviously, there's more people building on it, and the other two platforms are still, being built. From what I understand, I'm complete newbie in this space, but they offer smart contracts, or they will offer smart contracts for one of them, right? So why is it that Ethereum is better than, or considered, I guess, the gold standard of smart contracts? Just thoughts on that.
That's a really good question. And I think right now, especially with gas fees, we're starting to see a little bit of a reckoning where a lot of projects are thinking through like which chain makes most sense to be on, like where can I actually get scalability and stuff like that. But I think the biggest things about Ethereum are honestly like the culture and the community. Like Ethereum really grew organically and in a decentralized way, and its culture drew in a lot of people at the beginning. I know it did for me. The people are incredibly friendly and weird and excited and down to talk about new ideas. And there's this wonderful, wonderful community around Ethereum that I haven't seen even anything close to that anywhere else. Like regardless of crypto or even tech, it's something that I think is incredibly special. And then another big thing is that all of the users are pretty much on Ethereum and all of the liquidity is on Ethereum. And when we talk about DeFi especially, and wanting to basically connect platforms with other platforms or access liquidity, we're looking at Ethereum being by far the place with the most liquidity, whether I want to exchange a token or use a money market. So that liquidity, users, and community convergence is what I think has really given it a leg up. But it's going to have to, like, I think, make sure it continues to meet the demands of its users, especially with all these different scaling challenges.
Got it. Thank you so much.
For sure.
Alexis, I had a question earlier about executing smart contracts without using the front end. You're trying to find like something on Etherscan, but I found a transaction on Etherscan that interacted with 1inch.
Amazing.
Would you be able to kind of show us how?
Yeah, totally. Do you want to toss the link in the chat?
Yeah.
All right, cool. So let's go to Etherscan. All right, so let's hit up this 1inch smart contract. I love their vanity address. So then what I can do here on Etherscan is I can click on this tab called contract. And I can click, so this is a proxy contract. That's another pattern that people like to use. It basically allows you to upgrade contracts a lot of the time, but there are also other reasons that people would use proxies. But the cool thing about Etherscan is that it lets you write as proxy. So I'm going to come here and click write as proxy. And this is basically going to show me the different methods that I can execute on this smart contract. So writing would mean executing these transactions. Reading would mean reading data from the contract. So here I could see, okay, this is who the owner is. The contract is not paused. So this lets me read data. But if I actually wanted to execute a transaction, I could come here and do that. So for example, if I wanted to make a swap on 1inch, what this is doing is basically surfacing the swap method to me directly and surfacing the different parameters. So I could fill out these parameters with whatever, like, the address of whoever whoever is calling the contract, I'd have to look at the contract to see exactly what they mean by this. The amount I want to swap and fill out the rest of the parameters, and then I can actually execute that transaction. But as you can see, executing these kind of transactions does require an understanding of like not only what each of these parameters mean, but what the right format is to put into these different slots. So for example, should this be in ETH, or should this be in Wei, or should this be in Gwei? And even, those small subtle changes will result in you being able to execute that function or not. So those are kind of the challenges with executing at a smart contract level. You have to really understand the parameters and what's going on. And some protocols are so well documented and make this so easy. For example, I think Compound has incredible documentation, and like they make it so easy to call their functions, either using an API like Ethers or something like Etherscan. But for protocols where you don't know the documentation, it can be definitely challenging to do it without a front-end interface.
Got it. Thank you. I didn't actually know you could do that on Etherscan.
Yeah, super helpful.
What was the difference again between write as proxy and write contract?
Yeah, it's a good question. So write contract here is pretty much like not really going to give me much. Oh, it's giving me the same things. Weird. This looks like is this actually a proxy contract? Okay, I'm gonna have to look into it. At least with like most proxy contracts I've seen, what you're doing is you're separating your logic and your storage so that you can update your logic. So it's a common pattern for upgradability, where you'll have one contract where you have the logic for how that contract operates, and then another contract where you've got the actual data that you're interacting with, which allows you in the future to upgrade the logic contract to a new set of logic that can still talk to that old data that exists. And so typically, you need to use the proxy in order to like actually access the contract, and the normal contract is just a pointer to this proxy. So that's typically how the pattern works. This is a little weird that it's giving me read and read as proxy is the same thing. So I'm not sure actually how they've implemented it. I would have to take a look.
Okay,
Yeah.
great. Thanks, Alexis.
Yeah. Okie dokie. Well, if you don't have any more questions, thanks y'all for joining today. This was really fun. I'm so excited that so many of y'all came, and I will see you hopefully on the Discord, where we can continue chatting about more fun stuff. All right. Thanks, y'all.
Thank you.
Thanks so much.
All right. Bye.